In my previous video, I discussed how to solve linear programming problem by graphical method. Today, I am going to discuss few special cases in solving linear programming problem. First, I am taking the case of infeasible solution. It is better to understand by graphical method. In the case of algebraic method, that is in simplex also, this type of case may arise. But in that case, it is very difficult to visualize how it is, but some conditions you will see when it will be a case of infeasible solution. So to understand infeasible solution, I have taken this problem. Okay. Infeasible means in that case you will get no solution for solving linear programming problem. The problem is minimize this function subject to these constraints. So I am taking the graphical method to understand this infeasible solution. First, you have to plot the graphs on the graph paper, all these constraints. How we'll draw the graph that I have discussed in my previous problem. If you have any doubt, you can check. But still, again, I am doing this problem. We have to first plot the constraints to the graph paper. If you have no the standard graph paper, you can draw in this way roughly, and it will serve the purpose. First, take the equation 1. In this case, it is in equations, but to plot it first, you will equalize it. So from equation this constraint 1, we can write this 2x1 plus 3x2 is equal to 1200. Okay, this is 1. Now, actually, I will use the concept of straight line equation in the form x by a plus y by b is equal to 1. I have already discussed in my previous video. If the straight line equation is in this form, then say if it is x and this is y, then from x it will cut a, and from y it will cut b, and the line will be this. This concept we will use to draw the lines on the graph paper. I have taken this method. There are so many methods, no problem. But I think this is easy. To get one, both sides you divide by this. That is 1200 divided by 1200. So that I can get is equal to 1. No problem. As same quantity I have taken for dividing both sides. That is x1 divided by 600 plus x2 by 400, because if we divide by 3, that it will be is equal to 1. This is the first constraint. Then we have to put on the graph paper. From x1, you will take 600, that is this point, and from this is x1, this side is x1, and this side is x2 on the graph paper. x2, you take 400, that is this point. Then draw a line by this. Then how will be the line? I am taking the help of this stick so that the line is straight. Okay, this is the line that I have shown in my previous video, how this line is plotted. As this is the condition greater than is equal to, not less than, that means the direction of this line will be this. The direction of this line will be this. Okay, because if instead of 1200, if there is 1300, then what will happen? Then both value will be increased. That means the line can be moved in this direction because it is greater than is equal to. First you will draw the line and then you indicate the movement of the line. Now from constraint 2, from 2, it is better you take different color. Okay, okay, you take different color, it will be better. The different second constant is x1 plus x2, x1 plus x1 plus x2 is equal to 400. This is 2. Divide both sides by 400. You will do this in separate line, but to save the space I am doing on the same line. Okay, 400. Then next, that is x1 by 400 plus x2 by 400 is equal to 1. That means 400 is this and 400 again this, and you will get the line in this way. By joining these 2 points, we will get the line as this. Then what will be the direction of the line? As it is less than, that's why the direction of the line will be this. I'm not drawing everywhere. The movement of the line is this. I think it is clear. If you have any problem to understand how the lines have been drawn, you please check the previous video. Then it will be easy for you to understand. Okay. Now take the third constraint. Due to shortage of space, I am writing here from constraint 3. From constraint 3, you can write 2x1 plus 1.5 x2 is equal to 903. You will write just below the, as there is no space, that's why I am using this space. I think no problem. Divided both sides again by 900. Then what will happen? That is x1 divided by 450, because 450, if you divide by 2, and plus x2 divided by how much? 600, because 1.5 is 900 is equal to 1. The equation is similar to x by a plus y by b is equal to 1. X by a plus y by b is equal to 1. This m is cutting from x-axis. This is cutting from x2, in this case y-axis. Okay. Now put the points on the graph paper. 450. This is 400 and 500. So this is the 450. I'm taking different color. And x2 is 600. This is 600. You join the line and you will get another constant. This is greater than is equal to. That means the line is this. Line will be this. Slightly, it may be upper or the, this is greater than. This is greater than. Okay. This is greater. This line is greater than. And other conditions are, that is non-negativity constant x1 and x2 greater than is equal to 0. That is, if x1 greater than is equal to 0, that means the line is this direction. x1 greater than is equal to 0. And x2 greater than is equal to 0 means x2 greater than is equal to 0 means this side, in this way. x2 greater than is equal to 0. Then you see here is the points which is outside these constraints. This constraint will not satisfy in this place, and this constraint, as it is a lower direction, is not satisfy this constraint. In this way, all the constraints has not covered any common space. That means there is no common feasible area where all the constraints are satisfied. My point is clear. देखो यहाँ पर कोई ऐसा जगह नहीं है, यहाँ पर ऐसा जगह नहीं है, कुछ जगह ऐसा नहीं है जहाँ सारा constraint satisfy हो रहा है. मानो कि यहाँ if your solution is here होता है, तो this is not satisfied by this constraint. तो ये constraint अलग है और इधर ये constraint अलग है. ये तो हो गया, but it is not satisfied. If you take this point, suppose in this area, तो ये constraint will not satisfy because they are outside. Upper bound, this is lower side, this is bounded, but this constraint will miss this area. This constraint will miss this area because this is upper bound. Upper movement, the line is moving upper side. That's why you can say ऐसा कोई जगह नहीं है जहां सारा constraint satisfy कर रहा है. In your previous problem, you check our solution lies on the common feasible area. First of all, we draw all the constraints and try to find out the common feasible area. और तुम्हारा solution उसी में है. और सॉल्यूशन कहाँ होता है? एनी कॉर्नर पॉइंट एज पर algebraic laws of Hadley that I have mentioned there. तो यहाँ पर कोई कॉमन फिजिबल एरिया नहीं है. यहाँ अगर देखते हैं इस एरिया देखते हैं तो ये सेटिस्फाई नहीं करता है, यहाँ देखते हैं ये दोनों का इधर तो ये सेटिस्फाई नहीं करता है. तो इन दिस वे कोई ना कोई जगह ऐसा है जो सारा कॉन्स्ट्रेंट सेटिस्फाई नहीं कर रहा है, एंड दैट इज द रीजन तो इसमें कोई फिजिबल सॉल्यूशन नहीं मिलेगा. एंड दिस इज द केस ऑफ इनफिजिबल सॉल्यूशन. जब सिंप्लेक्स अप्लाई करोगे तब वहाँ पर भी इस तरह का सिचुएशन आ सकता है, एंड इट विल बी अंडरस्टूड थ्रू एल्जेब्रिक कंडीशंस. कौन कंडीशन है? यू कैन डिक्लेयर दिस इज ए केस ऑफ इनफिजिबल सॉल्यूशन, एंड तुम्हारा आंसर हो जाएगा यू कांट सॉल्व दिस लीनियर प्रोग्रामिंग प्रॉब्लम. आई थिंक इट इज ओके. तो ये एक स्पेशल केसेस मैंने दिखाया जहां तुम्हारा सॉल्यूशन नहीं हो सकता लीनियर प्रोग्रामिंग. दैट्स व्हाई आई हैव डिस्कस्ड सेपरेटली. थोड़ा सा मैं अगेन ब्रीफ कर देता हूँ. दिस इज द प्रॉब्लम. मिनिमाइजेशन का बात तो बाद में आ रहा है, मिनिमाइजेशन होगा कि मैक्सिमाइज, वो तो बाद में. फर्स्ट ऑफ ऑल सॉल्यूशन तो मेरा कॉमन फिजिबल एरिया होना चाहिए. कॉमन फिजिबल एरिया मीन्स जहाँ पर सारा कॉन्स्टेंट जितना गिवन कॉन्स्टेंट्स है वो सेटिस्फाई कर रहा है. कॉमन स्पेस मिलना चाहिए. दैट इज द बेस्ट फॉर सॉल्विंग लीनियर प्रोग्राम. तो ग्राफिकल मेथड में हम क्या करते हैं, सारा ग्राफ को मैं ग्राफ पेपर पर प्लॉट करते हैं, और उसका मूवमेंट का डायरेक्शन बहुत जरूरी है. इसका बिना कोई मीनिंग नहीं है. अगर ये लाइन उल्टा हो जाएगा तो उसका मीनिंग उल्टा हो जाएगा. तो ग्राफ कैसे प्लॉट किया जाता है वो तो आई हैव ऑलरेडी डिस्कस्ड, दिखाया भी है. फर्स्ट इक्वेशन, इन इक्वेशन से कांस्टेंट को उठाया, ये मेरा एक्स वाई है, वाई वाई ये सारा इस तरह से दिखाया. उस तरह से मैंने फर्स्ट इक्वेशन को प्लॉट किया. फर्स्ट इक्वेशन कौन सा था? दिस इज द फर्स्ट कांस्टेंट था, ये फर्स्ट. सेकंड कौन सा था? तो बड़ा 400 वाला जो है, सॉरी ये सेकंड है, सॉरी. दिस इज द सेकंड. फर्स्ट कौन सा था? 600 एंड 400, दैट इज 600. ई वाला था तो बड़ा फर्स्ट कंडीशन. फर्स्ट ये जो 1200 जो है ये दिस इज द फर्स्ट कंडीशन का लाइन. और थर्ड कौन सा है? थर्ड है ये 450 एंड 600, एंड दिस इज योर थर्ड कंडीशन. ये प्लॉट करने के बाद ये पता चला कोई कॉमन स्पेस नहीं है. जैसा ये लाइन जो है यहाँ पर नहीं है, सेटिस्फाई नहीं करता है, तो डायरेक्टली इधर है मूवमेंट. तो यहाँ पर अगर सॉल्यूशन निकलेगा तो ये तो सेटिस्फाई नहीं करेगा. यहाँ पर देखते तो ये सेटिस्फाई नहीं करेगा, या अगर ये पकड़ता है यहाँ पर सॉल्यूशन है तो ये भी सेटिस्फाई करेगा. इस तरह से यू कैन चेक मैन्युअली जो कोई कॉमन स्पेस यहाँ पर नहीं है, एंड फॉर दैट रीजन इसका सॉल्व तुम कर नहीं सकते. यू कांट सॉल्व इट, एंड इट इज ए केस ऑफ इनफिजिबल सॉल्यूशन. तो फर्स्ट स्पेशल केस इज ओवर. तो मैं दूसरा केस अभी ले रहा हूँ. ओके, तो आई हैव टू इरेज इट टू गेट द स्पेस. तो इसको मैं इरेज कर देता हूँ. सेकंड मैं दिखाऊंगा अनबाउंडेड सॉल्यूशन. ये क्या होता है अनबाउंडेड सॉल्यूशन? पहले प्रॉब्लम को मैं दिखाता हूँ प्रॉब्लम, तब उसके बाद मैं इसका सॉल्व करेंगे. ओके, नेक्स्ट अनबाउंडेड सॉल्यूशन. द प्रॉब्लम, this is the problem. Maximize unbounded solution. Okay, maximize, but just लिख ही देते हैं. Second case unbounded solution. ये किस तरह से होता है ये अनबाउंडेड सॉल्यूशन? पहले प्रॉब्लम को लिखते हैं. सपोज maximize, problem is this, maximize z is equal to 120 x1 plus 160 x2, subject to p constant यह है 3x1 plus 4x2 greater than is equal to 2400. This is number one. Second, 2x1 plus x2 greater than is equal to 1000. ये दूसरा कंडीशन है. एंड थर्ड, 5x1 plus 3x2 greater than is equal to 2900. ये तीसरा कंडीशन. दिस इज सेकंड. और नॉन नेगेटिविटी कॉन्स्टेंट. दिस इज द प्रॉब्लम. तो अब मैं दिखाता हूं कि अनबाउंडेड सॉल्यूशन क्या होता है. वो दिखाने के लिए again you have to plot the constraints on the graph paper. तो हमारा पास तो कोई फॉर्मल ग्राफ पेपर है नहीं, तो roughly you can draw this graph. ठीक है, चलो कर लेते हैं. Okay, now say 1, 2, 3, 4, 5, 6, 7, 800, 100, 200, 300, 400, 500, 600, 700 and 800. 1, 2, 3, 4, 5, 6, 7, 8 and 10. 100, 200, 300, 400, 500, 600, 700, 800, 900 and 1000. In this case, you move 1000. So we have to plot all these constants to the graph paper as we have done in my previous one. Take one equation, the same concept, x by a plus y by b is equal to what? This form of straight line we use to plot the graph. इस तरह का फॉर्म में है तो x से a कट किया, y एक्सिस से b कट किया, इस तरह से लाइन ड्रॉ कर सकते हैं. तो फ्रॉम वन एक एक करके करते हैं. फ्रॉम वन 3x1 plus 4x2 is equal to 2400, 2400, 2400 and divided by 2400. That is x1 divided by 800 plus x2 divided by 600 is equal to 1. The first equation will be, this is 800 and this is 600. The line will be this. I am drawing the line. And what will be the direction? Greater than is equal to. That's why the direction of the line will be this. Okay. Now I am taking the second from to be better to write by different color. To be better. From 2 the equation is 2x1 plus x2 is equal to 1000. Then divide both sides by 1000 divided by 1000. That is x1 divided by 500 plus x2 divided by 1000 is equal to 1. 500 means this point, and 1000 means this point. Right? You draw another line by this. This is another constant. It is also greater than is equal to. That's why the direction will be this. The direction will be this. The direction will be this. Okay. Now, third constant. I am taking this constant in this place as we have not sufficient space. That's why. Five x1 from 3 is the 5x1 plus 3x2 is equal to 2900. divided by 2900 as you have done earlier. 2900 divided by 2900, that is x1 divided roughly 5, which is 580, which is 480 I think, plus x2, this divided by 3, 9 27, 53.6 is equal to 1. So we can draw this line to the graph paper. 580, roughly say this is the place of 580, and 966 say this is the point, and we have to draw another line. It will be this. Draw the line by this 2 point is this. This is the third line. Again, this is also greater than is equal to, this is also greater than is equal to. You can say this is also greater than is equal to. This is one cutting point, and this is one cutting point, and this is one cutting point, and this is a point. So you can say the common space is all are greater than is equal to, if this is O, and you can say A, and the O, A, B, and C, and the area is this. The common space is open from above direction, because this is greater than is equal to, all these are greater than is equal to, this is also greater than is equal to, and the common space, this is the cutting point, this is the cutting point, it is above it. And that's why if you want to find the maximum value, suppose z is a function for maximization, and this is also a straight line equation. I don't know why the shape will be, but say this is the line, and if you move the line upward direction to get the maximum value, and your solution will lie on this common space, and you can increase this line. If you increase the value z, then the line will be shifted upward direction. Okay, but as the common space is open, that's why this line may move up to infinity. Hence, you cannot be definite what will be the maximum value, and this is a case of unbounded solution. Is it clear? But same problem, if you want to find out the minimum value instead of maximization, if it is a case of minimization, then there is a solution, because in that case the minimum point lie or any corner point, this O, A, B, C, and you have to check for which corner point the value is minimum. That will be the solution. Is it clear? That means for minimization of this problem, it is valid. You can get the solution, as minimum is the सबसे minimum जो value है, and that will, the common space is this. This is not under the common space. Your solution may not lie here, because in that case this constant not satisfied, not lie here, not lie here. But this is also going upward, x1 and x2. This is also given. This is x2 greater than is equal to 0. This side is say x1. This is the x2. Then that is the common space is only this. This is the common space. This, and this side. But if you want to get the minimum value, and this is the objective function, this is the straight line also, and we'll change the value of z, then the line will be movement. You can see y is equal to if mx plus c, we know that the line is this. This is the gradient, cutting point. So if c change, then the line will move. Okay. Similarly, you can say, so line will be move upward or downward. So this is the problem which is called unbounded solution in the case of, if it is a problem of maximization. Why it is unbounded? That I have shown. Maximum value will be the movement of upper side. It can go any extent to the infinity. But the same problem is a feasible solution if it is a minimization problem. If the objective function is minimized, then your minimized value will lie in this common set, common space at the minimum. You have to find out the minimum value by putting the coordinate of the corner point. Your solution cannot be here, cannot be here, cannot be here, but any point here, because in the open space है यहाँ पर सारा condition satisfy हो रहा है, ये भी greater than is equal to, ये भी greater than is equal to, greater than is equal to, even your this is your x1 greater than is equal to 0, this is x2 greater than is equal to 0, upper movement. So this is a case of unbounded solution. If you have any problem, you please write to the comment box. I will again explain. No problem. Okay. Now the third situation of this few special cases. So I have already discussed the infeasible solution, unbounded solution. Now I am going to show you another situation, which is also, you can say, a special type of situation. You should know it so that when we try to solve that situation may come and your answer will be according to the situation. In this case, you will write your answer will be as your common space is infinite. That's why there is no solution, and it is a case of unbounded solution. Now, next problem we are taking, that is redundant constraints. What is the situation? Redundant constraint. Now I am taking another problem. Say this is a case of redundancy of constraint. First I am writing and showing you the solution, then I will discuss what is the speciality. Problem 3. Okay, first maximize z is equal to 1170 x1 plus 1110 x2 subject to 9x1 plus 5x2 greater than is equal to 500. This is number 1. Second, 7x1 plus 9x2 greater than is equal to 300. 2. 5x1 plus 3x2 greater than is equal to, sorry, this is less than is equal to 1500. Third, fourth, 7x1 plus 9x2 less than is equal to 1900. This is 4. And 2x1 plus 4x2 less than is equal to 1000. This is the problem, and your negativity constraint x1 x2 that must be given, otherwise you will not get any closed set. Okay, so first I am doing the graph paper. You have to draw the graph for the graph paper. I am showing all the problems through graph, all the situation. It will be easy to understand. Okay, it will be easy to understand. So this is x1 and this is x2. 1, 2, 3, 4, and 5. 100, 200, 300, 400, and 500 in this one. 1, 2, 3, 4, 5. 100, 200, 300, 400, and 500. Solution. Again, we have to put all these constraint on the graph paper. One by one, I will take it. First, from 1, from from 1, you can write 9x1 plus 5x2 is equal to 500. This is 1 divided by 500. 500, 500 and 500. That is x1 first term 45, 45 and 5 roughly, and plus x2 divided by 100 is equal to 1. And if we plot on the graph paper 55, 55 means 50 is this, 55 this is 55 point, this is 1 point, and 100 is another point, and the graph will be this is greater than is equal to. For that reason I'm first drawing the line and they put the direction. Okay, and the direction will be this first equation. Now second. Now second is from second, this is from 2. The equation is 7x1 plus 9x2 is equal to 300 divided by 300 divided by 300 divided by 300. That is x1 divided by roughly approximate 43 28 to plus rough x2 divided by 17.3 is equal to 1. x1 43, 43, this is how much? This was 55, this is 55.5, 43 means, so this is the point, say 43 roughly, 43 and 33.3, this is 50 and 33.3 means, so this is 33.3. So you will get this line, that is also greater than is equal to, that is also greater than is equal to, you will get this line, you will get this line, that is also greater than is equal to. This is your second constraint, this is second, and this is equal to first constraint. Okay. Now third. Now this third. What is third? I'm using this space. Third constraint from 3. From 3, it will be 5x1 plus 3x2 is equal to 1500 is equal to 1500 divided by 1500 divided by 1500 and divided by 1500. So that is x1 divided by 300 plus x2 divided by 500 is equal to 1. x1 300 means this is the point, and 500 is this is another point. By this we have to draw a line. I have to draw a line. The line is this. Achha. And the condition is less than is equal to. The direction of the line will be this. The direction of the line will be less than is equal to means this. I think it is okay. Now next fourth one. From 4. I'm writing here from 4. As we have less space, that's why I'm writing here 7x1. It is better to take different color. Next, fourth, 7x1 plus 9 and x2 is equal to 1900. 7x1 plus 9x2 is equal to 900 divided by 900 divided by 900 divided by 1900, or x1 divided by the 7 right, roughly this, plus x2 18 1.1 is equal to 1. 271. So this is the point, 271, and those 11. So this is the point, another point, and we'll draw the line in this way, and the movement of the line is, this is your fourth condition, less than is equal to, this is less than, that's why the condition is this. This is fourth condition, and last is this. From 5, the criteria from 5 can note 2x1 plus 4x2 is equal to 1000. Okay, then divided by 1000 and divided by, or that is x1 divided by 500 plus x2 divided by and is equal to 1. So x1 divided by 500 means this is a point and another is 250. So this is a point, another point. So you have to draw the line in this way. To draw the line, and again this is less than is equal to, that's why direction of the line will be this, direction of the line with this, and this is fifth condition. Okay, and non-negativity constraint means this is x1 greater than or equal to 0 and x2 greater than or equal to 0. In this way you can plot all the graphs, all the lines on the graph paper. Now you see minutely, बढ़िया से देखो, जो the common space is here, the common space is here, this is the common space, this is the common space जहाँ पर सारा कंडीशन सेटिस्फाई किया है. यहाँ ये ग्रेटर लेस देन इक्वल टू है, ये भी लेस देन इक्वल टू है, ये ग्रेटर देन इक्वल टू है, ये भी ग्रेटर देन इक्वल टू है. तो दिस इज द कॉमन स्पेस जहाँ तुम्हारा सॉल्यूशन मिलेगा, जहाँ ये ऑब्जेक्टिव फंक्शन जो मैक्सिमाइज हो जाएगा. तो ये कॉमन स्पेस में ये कॉर्नर पॉइंट पर आएगा, ये चारों कॉर्नर पॉइंट. दिस इज ए बी सी एंड डी. यहाँ आंसर नहीं हो सकता. क्यों नहीं हो सकता है? बिकॉज दिस कॉन्स्टेंट विल नॉट सेटिस्फाई. यहाँ नहीं हो सकता, यहाँ नहीं हो सकता है, यहाँ नहीं हो सकता है, बिकॉज इन दैट केस दिस कॉन्स्टेंट विल नॉट सेटिस्फाई. यहाँ भी नहीं हो सकता है, यहाँ नहीं हो सकता है. कहाँ हो सकता है? ओनली ये जो, तो ओनली दिस टू कॉन्स्टेंट्स आर इनफ. ये जो है तुम्हारा ये कॉन्स्टेंट कौन सा है? एक नंबर कॉन्स्टेंट, ये एक नंबर, ये और ये कॉन्स्टेंट कौन सा है? 4 नंबर. ये दोनों कॉन्स्टेंट इज इनफ टू सॉल्व द प्रॉब्लम. बाकी कॉन्स्टेंट जो है अननेसेसरी है, रिडंडेंट है. दिस इज कॉल्ड ए केस ऑफ रिडंडेंट कॉन्स्ट्रेंट केस. तो क्यों इतना मेहनत किया? मेहनत करने का फायदा ये है कि मानो कि अगर कोई ये सिंप्लेक्स से सॉल्व करना है, तो इफ़ यू ट्राई टू सॉल्व दिस प्रॉब्लम तो अननेसेसरी प्रॉब्लम लंबा हो जाएगा, क्योंकि सारा कॉन्स्टेंट लेके चलोगे. लेकिन यहाँ हमने देख रहे हैं इसका कोई ज़रूरत नहीं, इट इज़ नॉट रिक्वायर्ड. ये नहीं भी रहेगा तो आंसर तुम्हारी दोनों से ही ये प्रॉब्लम चल सकता है. तो दिस इज द मिनिमम कॉन्स्टेंट्स विच आर रिक्वायर्ड टू सॉल्व द प्रॉब्लम. बाकी जो है रिडंडेंट है. रिडंडेंट क्यों है? क्योंकि ये जो है ये तो ऑटोमेटिक ये भी सेटिस्फाई कर रहा है. यहाँ भी बोलोगे लेस देन इक्वल टू, ये भी सेटिस्फाई कर रहा है. तो ये भी रिडंडेंट है. कौन कौन रिडंडेंट है? इसका जरूरत नहीं है, इसका कोई ज़रूरत नहीं है, इसका भी कोई ज़रूरत नहीं है, इसका भी कोई ज़रूरत नहीं है. ये रिडंडेंट है. केवल ये दोनों दे देता है तो सॉल्यूशन मिल जाएगा. तो सिंपलेक्स मेथड में हम क्या करेंगे? ग्राफ से मैंने देख लिया, तो ओनली दिस टू कॉन्स्टेंट विल टेक एंड देन गो अहेड. तो प्रॉब्लम बहुत छोटा हो जाएगा. तो दिस इज द कॉन्सेप्ट ऑफ रिडंडेंसी. आई थिंक इट इज क्लियर. तो आज मैंने 3 स्पेशल केसेस को डिस्कस किया. फर्स्ट मैंने डिस्कस किया क्या? इनफिजिबल सॉल्यूशन. कहाँ सॉल्यूशन फिजिबिलिटी नहीं हो सकता है. सेकंड अनबाउंडेड सॉल्यूशन. अनबाउंडेड कब होता है? जब तुम्हारा क्लोज सेट बाउंडेड नहीं है, वहाँ सॉल्यूशन इन्फिनिटी तक जा सकता है. वहाँ पर भी मैंने देखा है सेम अनबाउंडेड सॉल्यूशन सॉल्व कर सकता हूँ, बट इफ द ऑब्जेक्टिव फंक्शन इज इन डिफरेंट डायरेक्शन. मिनिमाइजेशन का केस में हो सकता है, लेकिन जैसे मैक्सिमाइज पूछोगे तो सॉल्व नहीं हो सकता. अनबाउंडेड इन्फिनिटी तक चला जाएगा. इन्फिनिटी तो कोई डेफिनेट नहीं है. और तीसरा मैंने स्पेशल केस दिखाया जिसको बोलते हैं रिडंडेंट कॉन्स्टेंट, अननेसेसरी एक्स्ट्रा कॉन्स्टेंट्स. वो कैसे, वो मैंने दिखाया. तो ये जो है ये ज़रूरत का चीज़ है, बाकी जो है ज़रूरत नहीं है और अननेसेसरी है. तो दिया तो तुम चेक करके देख सकते हो. ये नहीं भी रहेगा तो प्रॉब्लम सॉल्व हो जाएगा, नहीं भी रहेगा तो प्रॉब्लम सॉल्व हो जाएगा. जो प्रॉब्लम तुम्हारा आंसर आएगा वही, लेकिन केवल ये देने से नहीं होगा. यहाँ पर सॉल्यूशन नहीं आ सकता, तो मैंने एक बार बता दिया. यहाँ भी सॉल्यूशन नहीं हो सकता है. इनमें मिस होता है। और फिजिबिलिटी तुम्हारा सॉल्यूशन जो ये चारों कॉर्नर पॉइंट का कोई एक पॉइंट पर होगा। अगर ग्राफिकल मेथड में सॉल्व करोगे, हमें सॉल्यूशन यहाँ पर नहीं जा रहा है कि ऑलरेडी आई हैव शोन यू हाउ टू सॉल्व। तो चारों कॉर्नर पॉइंट पर मानो कि ये ए है, इसका कोऑर्डिनेट जानते हैं, इसका कोऑर्डिनेट जानते हैं, तो ऑल्सो नो द कोऑर्डिनेट ऑफ दिस। ये चारों कॉर्नर पॉइंट पर ये ऑब्जेक्टिव फंक्शन का वैल्यू निकालोगे, एंड एज इट इज ए केस ऑफ मैक्सिमाइजेशन प्रॉब्लम, जिसका सबसे हाईएस्ट वैल्यू रहेगा उसी को रख लेना है, वही तुम्हारा आंसर हो जाएगा। तो इतना ही आज। तो हम समझते हैं कि हैव अंडरस्टूड ऑल दिस। अगर किसी भी प्रॉब्लम है, किसी तरह की भी प्रॉब्लम, डोंट हेजिटेट, कमेंट बॉक्स में डाल देना, और डेफिनेटली आई विल रिप्लाई एट द अर्लीस्ट पॉसिबल। और अच्छा लगे तो एक लाइक दे देना, इट विल मोटिवेट टू डू फर्दर वीडियोस। मैं जल्दी फिर नेक्स्ट वीडियो लेके आ रहे हैं, तो थोड़ा दूसरा टॉपिक हो जाएगा, क्योंकि लीनियर प्रोग्रामिंग में मैं करीब करीब ऑल टाइप ऑफ प्रॉब्लम्स मैंने देखा लिया, सिंप्लेक्स भी देखा लिया, सिंप्लेक्स में मैक्सिमाइजेशन प्रॉब्लम भी दिखा लिए, हाउ टू सॉल्व मिनिमाइजेशन प्रॉब्लम सिंप्लेक्स में वहाँ भी दिखा लिए, बिग एम टेक्निक्स का डिस्कस कर लिए हैं, उसके बाद ग्राफिकल सॉल्यूशन भी डिस्कस कर दिए हैं। आई हैव ऑलरेडी डिस्कस ऑन हाउ टू प्लॉट द लाइन्स ऑन द ग्राफ पेपर, वो भी डिस्कस कर लिए हैं। आज मैं कुछ स्पेशल केसेस भी रख लिए हैं। ऐसा तो बहुत है, सब डिस्कस करना पॉसिबल नहीं है। इफ़ यू हैव एनी इंटरेस्ट फॉर एनी स्पेसिफिक प्रॉब्लम, तो अगर बताओगे तो डेफिनेटली आई विल सॉल्व इट। ये प्रॉब्लम तुमको इग्नू ब्लॉक्स में भी मिल जाएगा, उसका ऑपरेशंस रिसर्च ब्लॉक में मिल जाएगा, यू कैन चेक फ्रॉम दैट ऑल्सो दिस टाइप ऑफ प्रॉब्लम। तो थैंक यू, आज के लिए इतना ही, थैंक यू।